Hi everyone, I'm Sagar Kulkarni. We are handling the MEP designs in Dubai. Companies established about 13 years back. And apart from UAE, we have been handling projects in Africa as well as in India. We handle multiple projects, and it's glad to get interacting with you for the subject of MEP design for one of the projects we are handling in Istanbul. As the whole thing proceed further, we'll introduce about the MEP, the interaction of MEP services with architectural details, how the systems work, what as an architect you should consider for incorporating the services in the building, the particular details of your building which you are working on, the office building in Istanbul, what are the parameters which are there. And at the end of the session, we have some time where if you have some questions, queries, we will be glad to address your questions. So I'll start with a presentation. I'll share the details. I hope everyone can see the screen.
Yes.
Yes, it's a designing of office tower by Manipal, and we are trying to co-host or give our inputs related to the MEP works. Now, a small introduction of what exactly we are considering. When we talk about any project, that project has different components or the parameters where you are supposed to evaluate the requirements. Apart from structural and architecture, all other aspects are interactive with the end user. So when we as a MEP team or the consultant start interacting with the client and architects, we ask few questions or we consider few parameters. Which of those parameters are notified here as a part of content, like chief consideration of building design, climatic conditions, where the building is getting constructed. Like Istanbul is not having the harsh weather conditions as of UAE, where air conditioning becomes a key part. If the building is getting constructed in Africa, the conditions are different, where we have heavy rainfalls. The infrastructure network between developed countries and developing countries, that becomes a difference. So that has an impact on the designing of architectural as well as the services. Authority guidelines, whatever we are developing, constructing, at the end of the day has to get certified by authorities as a building permits. So they have their own guidelines, plus at times they are asked to follow some international standards. So there are different standards for different services. There will be some standards for architecture also. Similarly for air conditioning we have standard, for the electrical we have standards. So which are the standards which are there and how it impacts the building design. Then we'll talk specifically, when we talk about office, what exactly we should consider. Normally office spaces are considered as shell and core, where each tenant will have his own requirement and the master developer or the base build will provide the infrastructure for them. So how it is handled, any specific client requirements he has any, and considering all above points, a designer's role will come into picture. Then we'll discuss the distribution of MEP services. MEP will be a vertical distribution, which is floor to floor, and horizontal distribution, that is from the corridor to individual office spaces. So, and then a conclusion. So this will be a broad scenario of the whole presentation or the details. As we are talking about, apart from architectural and structural, rest everything for MEP is interactive. It is meant to suit the purpose of the occupant and end user. So let it be a lighting. So if the requirement of detailed work, then we have more lighting. To have comfort for the occupant, we need to have air conditioning. So the temperature should not be too cold, it should not be too uncomfortable. Similarly, we are talking about the water supplies. Apart from this, few requirements come into picture as the fire and life safety, which is required for the occupant safety in case of any accidents. So all these services are covered as part of MEP. By and large, when we evaluate it, it contributes about 30 to 40% of the cost of the whole project for the MEP during first as the initial cost or as the cost of construction. When we go further into the operation, these costs are about 90 to 95%. So it is important for all stakeholders to understand the selection and implementation of design, how it will work during the design and installation, and how it will perform during operation and maintenance. And those aspects we are going to have one by one as a part of further discussion. As we mentioned, climatic conditions, infrastructure, authority guidelines, client specific requirements are the key parameters for designer's role. Taking further to our particular project, Istanbul. Istanbul is just gateway to the Europe. So weather conditions are 20 to 30 degrees centigrade. Unlike Dubai, I was mentioning earlier, where we get temperature of about 46 to 50 degrees centigrade in the summer. So in such cases, we need AC. Normally, when we talk air conditioning, we maintain temperature of about 24 degrees centigrade as a comfortable temperature. So the AC requirement for the offices will be there, which will be required to improvise the efficiency of the workers, making them comfortable. But the load or the allocation of AC will be lesser as compared to the Gulf. Similarly, depending on the latitude and altitude of the site, the orientation of the whole facade will be considered. I believe that's a part of architectural thing, and you must be looking into it. How can we maximize the sunlight, and how we can create that atmosphere within the spaces. So when we talk about those things of maximizing the daylight, we automatically talk about reducing the artificial dependence on the lighting. Rainfall is again a key aspect. Our facade should be properly protected from the rainfall, and whatever rain is going to the premises has to be taken out of the plot effectively. So that will depend on the climatic conditions plus infrastructure both. Then when we say lighting facades with glass, it also brings the solar energy, which is radiant energy. How can we get more sunlight but less heat? That depends on the selection of the glass. So these are climatic conditions. At an infrastructure level, how the plot is. Whenever you want to construct the office tower, is it a flat? Is it sloping? If it is sloping, then it has to get properly leveled. So plot grade will come into picture. Allocation of utilities, what sort of infrastructure is available around the plot, from where I am getting the drainage connection, from where I am getting the water supply piping, from where I am getting the telephone lines. So all these things. In developed countries, there is something called master development. So as a master, each plot is allocated for a specific purpose, and the allocation of services in terms of power, X megawatt is allocated. So that comes into picture. Similarly, how much rainwater we can discharge. When there are heavy rains, we cannot flood the infrastructure. So the authorities, the guidelines of the master development will suggest that we should hold the water for 2-3 hours within the plot and then discharge to the main network to avoid flooding of the spaces. So those norms will come into picture as part of master development. Orientation we discussed, and soil condition, very important. How the structure will be there based on soil condition. Again, percolation of rainwater will come into picture. So these are the basic parameters on which the whole designing of structure as well as MEP is governed. Now standards. As we are discussing, for every location we have specific authority guidelines and international standards. So when we are designing it, there are four major parameters on we work on with authority. One is authority guidelines and international standards. Second, what is the infrastructure of the authority around the plot? Third, access and safety of maintenance. At times when we talk about civil defense, they come and they inspect quite regularly for the safety standards. So how they will access scenario. If you talk about the power distributor, they have to maintain their transformers and cables and they do regular inspections. So how can they access the areas for them? And last aspect is billing. The occupants will have two sort of billing. One is billing from the master developer, and second is from the authorities like electricity and water, as we pay for DEWA bills here, as we pay telephone bills here. Similarly, air conditioning is being handled at times with district cooling, so that will come to picture. So these are the aspects when we deal with the authorities, we look into. I just mentioned few standards which are internationally acceptable for the air conditioning and water supply and the services. I think as a part of architecture, you should just get introduced to it. In-depth analysis of this is not required. But second part for sure is required for you people, that connectivity to infrastructure. At the end of the day, the building has to function along with the periphery it is built with. So road and access to the roads, service entries are the parts which we'll be discussing as a part of your architectural details. Apart from that, we are talking about services entry, which is water supply, civil defense. When we say civil defense, if in case of any mishap, how the civil defense vehicles, fire hydrants will get interfaced with the building to protect and minimize the damages. It also talks about if the fire stations are nearby the plot, then you need not have the heavy storage of the water because accessibility is there for a fire station. Power grid, digital connectivity, phone lines are the parameters to make the building live. Access and maintenance, escape route in case of emergencies, how people will be evacuated in shortest possible time. How in case of accident, how people can be segregated by keeping a refuge floor. So all this part becomes part of safety and maintenance. As I'm seeing, this is a high-rise tower. You will have multiple refuge areas where occupants are evacuated in staggered manner. And as we discussed about metering, we have mapped the details which were provided to us as what are the components and what are the services which will be applicable. So in retail, we are talking about almost everything will be applicable. But when we talk about entrance lobby, which is grand entrance lobby, we need not have water supply and drainage over there. So similarly, we go through each aspect and notify what sort of services are required. Once we get this basic matrix, then we go further with the calculations. Like going further, just for example, in basement, we don't provide AC. It is not required because there are no occupants. It's only a car park. So air conditioning will not be applicable. Water supply will not be applicable. But firefighting has to be there. We need to have power supply. Telephone data, we don't have the points, but the network should be there. CCTV is required. So each area of the building is analyzed for the services it needs. In services design, we get connection from the infrastructure at one certain point, which we say as a main center. From that main center, services are distributed to intermediate details, and from there it goes to the end user. How it happens for all services, we'll go one by one. When we talk designing of services and project, these are the few aspects we ask client. Who is the target customer? Looking at the facade of the building, we analyze this could be a high-end group, where we are talking about sophisticated offices. Now the offices are in sell mode or lease mode. When we are talking about these differences, it goes with the billing, because in case of lease mode, the tenant is paying for the premises lease, and all common utilities like elevator, like corridor air conditioning, like maintenance of FMC are loaded on the rentals. So what that component is has to be evaluated and notified to the building operators, so that the lease of the space is decided accordingly. So we asked fundamentally this question. Then what is the building height? Normally we keep the pressures in the building less than 10 to 12 bar. Beyond that, it becomes difficult to handle it. It's dangerous. So when we say 10 to 12 bar pressure, the height correlates to almost 120 meters, 100 to 120 meters. Now, the notification says that 180 meters is the building height. That means you need to break the pressure. What it means is, for such building having height more than 100 meters, we need to introduce a mechanical floor, where a distribution of lower floors will happen from ground floor, and intermediate floor, say at 90 meter or 100 meter, halfway through, will be handled from the intermediate floor to above till roof. Second, all these things we are designing for the occupants. There will be full-time occupants, there will be part-time occupants. So what that combination will be? Either we can ask the developer for that, or there are standards available. So we have established the occupancy of about maximum occupancy of 11,200 people in the premises. These are the maximum occupancy. We need not design everything for this. There will be always diversities. All the spaces will not be occupied at all the times. So we work on that. Second is, as a part of designer, what are the shared services? Are we providing toilets common for the offices per floor, or we are supposed to have dedicated toilets for each offices? This will have operation versus cost impacts. So these are the questions we need to understand. Then shell and core offices versus totally furnished offices. I think we briefed on that. Shell and core will give the only tap off points and only screed to the end user, and he will furnish the office the way he wants. Second aspect comes. Hello. Okay. Second aspect is completely furnished office, where end user will come and he just plug and play. Everything will be available as a part of false ceiling, flooring. Only the loose furniture he will provide as per his requirement. So what sort of angle he would like to go through as a developer is what we'll further discuss. Again, the client requirements are evaluated, what he needs as a services in the building. Standard thing, air conditioning, water supply, drainage are the requirements as the end user. Fire protection and fire alarm is by the authorities. Power and telephone data is again as for the end user. CCTV and access control, that can be required either by authority or by surveillance for the safety of the building. So similarly, we have another aspects. If you, do you want gas? Is there any specific requirement? Do we have gym or swimming pool? So those requirements will come into picture. There are standards like well building. I'm not sure you are aware of now. As we talk about green building, where we talk about sustainability, there is something called well building standards, where we talk about the comfort, mental happiness of the occupants. So when such thing come into picture, they talk about fitness uh, and well-being of the building occupants. In that case, we need to provide the the gym facility, we need to provide rest facilities, we need to provide the washing facilities or the shower facilities. All these aspects will come into picture. So it all depends what client is trying to accommodate in the building as a part of standards. Once we get the basic information that what exactly is the building, how is the use, how are the occupants, what is the model, then we'll start working on the details. Now, from here, we'll start talking about specific services. Air conditioning. In air conditioning, we can see from window AC, split AC, there is something called package unit, there is new technology of VRF and chillers. So when to use what? Basically, as a thumb rule, anything which goes beyond 1000 ton, we use the chiller system. Now, how should we correlate this? That capacity is more or less proportional to the area and climatic conditions. Say in Dubai, we have a house or a space of 1000 square feet. So for 1000 square feet in Dubai, we'll need say 5 ton or 5 TR as a load. But same 1000 square feet, if I have office in Istanbul, I will need only 3 ton or 2.5 ton, half the capacity, because we don't have that extreme conditions. For Istanbul climatic condition, we anticipate almost 350 square feet per ton. So looking at the total built-up area of say 55,000 square feet, we are talking about more than 1000 ton as the cooling load. The approximate calculation is about 3000 ton. Now we cannot, the split units available or window ACs are available are in the range of about 3 to 5 ton. So we cannot have 1000 units installed on the roof where we have the piping of 1000 units, cabling of 1000 units. It's practically impossible. So the system which is adopted for such scenarios is a chiller system where we have high capacity chillers of 1000 ton, 2 or 3 chillers. There will be cooling towers on top, and heat from the space is taken out and released to the atmosphere. When I am saying this, we have the indoor unit where we call it the fan coil units. It takes the heat, it passes that heat to the water, that water gives the heat to the chiller, and chiller releases heat to the cooling tower, and cooling tower releases to atmosphere. So when this heat transfer happens between various areas, we need to have connectivity. So this is what we have. We are trying to show what is typical scenario. We are having a fan coil unit in the space which is connected to the chillers. Then the water is pumped from the chiller to the cooling tower, and from cooling tower heat is released to atmosphere. So all this horizontal piping will happen on particular floor in corridor. The vertical piping will happen in a shaft, and these are the mechanical floors where we keep chillers and pumps, and on the roof as a cooling tower. This will take further how the distribution happens. But predominantly, if you look into it, this is the main cooling source. Then we are talking about vertical distribution, as I was notifying earlier, which happens between floor to floor, and this is the horizontal distribution which happens within the floor from office to office. Now this air conditioning cannot be free, so we need to have the metering system. So the billing will be established based on the usage. If somebody is having more working hours or more occupancy, he will consume more AC, and accordingly he will be billed accordingly. Water supply, same thing. We cannot pump the water directly to the roof of high-rise tower. So whatever municipal network is there, which is connected to underground tank, the capacities are established based on the occupancy and consumption. Like for residentials, we have a high water consumption because we use for multiple purpose, for cooking, for bath, in offices that consumption is on the lesser side. So the water will come from the infrastructure to underground tank. It will be pumped to overhead tank with a pump. So we'll be having overhead tank. Fundamental thing for operation, it becomes easier that only first 4 floors will be using a booster pumps, and remaining floors, say about 100 meters or 120 meters, will be utilized with the gravity in the pressure. So we will generally, most of the countries, the standard is we should have minimum 1 day storage in the underground tank and half a day storage in the overhead tank. If we size overhead tank on a higher size, the structure becomes heavy because water has a heavy load. 1 cubic meter of water, the load is about 1000 kg. So structure becomes heavy. So half a day storage is kept on the roof and remaining is on the underground storage. We also need to analyze, as we discussed earlier, allocation. The toilets are common shared or they are provided in each office. Based on the number of fixtures, the consumption will increase and accordingly the capacities will vary. It is normally expected that in 8 hours a person will consume about 40 liters of water and a visitor will consume about 50 liters of water. Occupancies are considered about 110 people in 100 square meter for the offices. And based on that, the dimensions of the tank are evaluated. What should be underground tank? What should be the overhead tank? Again, same scenario. We are talking about vertical distribution in the shaft from the common source point and horizontal distribution in the corridor. So all the services which are talking about distribution will have these 2 alignments, vertical and horizontal. So the shaft has to be sized properly, as well as the corridor should have enough space to route all the services. While talking about water supply, and component will come into picture, hot water required or not required. If it's required, it should be centralized or it can be localized. Public health system, predominantly we talk about drainage, where we're taking the waste and soil out of the building and connect it to infrastructure. This system works purely on gravity. So it's a shaft of relatively high size, and if the buildings are of higher heights, the pressure of the water will be very high and there will be impacts. If the water falls from say 100 meter down to the lower joint, it will hit with a heavy pressure. So we need to break the pressures. So to break the pressure, easiest aspect without having much cost is provide bends in intermediate floors, say about after say 7 to 8 floors. If you give a bend, then the velocity is reduced and it will have lower impact on the lowest point. But when we talk about giving the bends for high-rise building in the drainage, we talk about additional shaft space. Normally, velocity breakers are given after each 5 to 6 floors. Now, this is not a day-to-day utilized system, but this is for the life safety and mandated by all the civil defense regulations. The famous standard all over the world is NFPA, which we say as National Fire Protection Association, worldwide used. It is American standard and followed by most of the countries in the world. Here again, we'll be having a tank in the basement, and with the pumps, it will be distributed to the sprinklers. It will be connected to the hose reel, which we say as a cabinet, where the occupants will use. And there's something called landing wall. So in case of the mishap is to a larger extent and the external agencies of the civil defense come into picture, they are authorized to use the landing wall, and they will connect their fire tank or their vehicle with the bridging inlets. It has a very high demand of the water requirement because in case of the accidents, the consumption of water is very, very high. So as compared to the domestic consumption, it will be more or less same or it will be more. If you look at the consumption of water for domestic it is 255 for half day, while the fire demand is about 227. So it's a huge water demand which is required. About timings, it depends on authority regulations and location of the fire station. If the fire stations are nearby, then storage capacity can come down. Again, this we have to discuss with the local authority to establish what they need. One is fire protection, second is fire notification. So there are fire alarm systems. In case of fire, the occupants are notified to evacuate the system. So either there will be an evacuation message or there will be a sounder system which will give the sound and alarms to the occupants to evacuate. Key aspect to move into whole scenario is a power distribution. So power from services provider. Here we talk DEVA, which is a government entity, but at different locations that you could have private players who will give the power distribution. Again, we evaluate the total power required. From infrastructure, it will come to a place called RMU, which is called ring main unit. When we talk such a big development, the power comes from two sources and connected at RMU level. When you say ring main unit, even if there is a problem in one source, at least second source will keep on feeding the power to the building. So during construction, during any accident, if one part fails, still the buildings are not affected for the power distribution. From RMU, it is connected to the transformers, which is shown here. Transformers have different ratings and capacities. With the details what we got, we are anticipating for the project consideration, we will need 8 megawatt power. So we have considered 4 transformers of 2 megawatt each. Apart from the transformers, we also need the generators. God forbid if anything goes wrong at a station level, still there are few services which are mandatory which need to operate. For example, elevator. Even if the power fails, the elevator need to work. So it will have generator supply. Suppose in case of a fire accident, the first thing civil defense comes is they will switch off the power of the main whole building to avoid any further damage. But in such cases, the fire horn should work. In such cases, there should be enough lighting for people to evacuate. So all such services will be hooked up with a generator power supply, which we call as emergency power. So we need space for transformer, we need space for generator, we need space for LV room. So the broad spaces we have established for the project are notified here. Again, all these major distribution will come on the ground floor. From the ground floor, we'll have vertical shafts where the cables run through, and then we'll have horizontal distribution at a floor level. So from RMU, the power is given to transformer. At RMU, it's high voltage, not recommended to get distributed because of the safety of the occupants. So it will be brought down to low voltage with transformer. Then we have LV panels. After LV panels is only on ground floor. Then on every floor we have SMDBs ground floor. And from SMDBs, the power will go to DBs horizontally. So all this cable will pass through corridors between SMDB to DBs, while the cables connecting LV panels to SMDBs will pass through vertical shafts. Same thing, telephone data. Here we have Etisalat and Do. They will provide the services at the center level. Normally, this is called main distribution frame, and space required for this is about 3 meter by 3 meter. With current scenarios of technology, we get telephone, data, plus we get GSM, and now CATV systems, which is we are talking about e-vision. Everything comes on common backbone, and space required for this at the ground floor is normally 3 meter by 3 meter. From this, vertically it goes to every floor through the shaft. Then we have IDF, which we say intermediate distribution frame. and from there horizontally it goes to the each office space or each end user. Access control, again, there are two types. One is permanent occupants of the building, who are the employees. Second are the visitors. So how can we segregate the entries of them? How can we handle visitors separately with the security check? So for that, there will be access points, gate barriers, access cards. We can have the swipe cards, proximity cards, or the biological or biometrical access systems. Apart from access control, there is also important aspect is of the security systems, which is CCTV. One is surveillance system and monitoring system, which is required by the developer. At times, government or the police also needs the data to monitor the proper surveillance, which will be interfaced with the authority under jurisdiction. So that interface has to get developed. Talking about Dubai, yes, Dubai, all public areas, common lobbies, corridors, elevators are monitored by Dubai police. CCTV, again the schematic, the main server systems. From the cameras, it is connected to the distribution frames, and these are connected to the racks, and it is distributed to the monitor. And this will be connected further to the remote surveillance system or station, which can be of Dubai police or something of that sort. When we talk about vertical distribution, we talk for the air conditioning, we need to have chill water pipes, we need to have ducts. For water transfer, we need to have pipes. Vertical public health, we are talking about 3 pipes, which is soil pipe, waste pipe, and main pipe. For electrical, we need shafts. These are typical distribution system, how the corridor works. Corridor are the most critical areas for us for MEP distribution. So it's already, these are always packed systems, and we have to also look from the operation and maintenance perspective, not only as a one-time installation, because all the systems are live. There will be leakages in the pipe because of the pressure as time goes, maintenance aspects. So we cannot go very aggressive in giving the spaces for the distribution of services. This is what the distribution will be from a typical corridor. All services like ducting, chill water piping, water supply, firefighting, this gets distributed. Predominantly, this services space required, if the corridor width is 1.8 meter, the space required is around 600 to 700 mm. If we reduce the corridor width to 1.2, then little bit height increases. This typically goes distribution ratio of the floor to floor height. Architects need to have maximum height for their aspect ratio, etc. So the floor height is getting governed by the services and the height the architect is looking for. So key takeaways. MEP systems are the functional systems. They are the interactive systems. Hence, it's crucial. It is very important to analyze the operations and how it will be handled post-construction, and those aspects need to get plugged into. Architect is not going to depth of the MEP design, but they should at least understand how the services are getting distributed, and they have to engage the specialists to get the inputs. The project is outcome of all stakeholders working together. So proper dialogue, understanding of these systems, and coordination are the key aspects for successful project. That's it. So we have given the brief description in the time frame which was stipulated to us. There are contact details if anybody has certain queries. our team will be happy to assist you.
So thank you, Sagar.
Yes, I hope I really time.
Perfectly well managed and really very customized to their project that they are currently working. And I'm sure they have some questions. So I'd like to unmute all so that they can ask questions. I think too much of noise. I think, yeah. So you can unmute yourself if you have a question one by one. So we can start and he can take up questions. Yeah, you can unmute yourself. You're not able to? Yeah, so please, you can share in, you have a question. Or you can put it in the chat. Yeah, one of the question, Sagar, was about refuge area. How many such spaces would be at intermediate level for a 40 to 45 floor of building?
Normally, the heights allowed up to 100 meters. So for your building, we expect around one refuge space. So intermediate, say, if the building at 90-meter level, we can have the refuge space. That space is also used as a pressure braking system. As I mentioned, beyond 12 bar, we don't allow the pressure to get built in the buildings. So at 90-meter to 100-meter is normally recommended space. So for this, it will be only one refuge floor.
Okay. Any other questions? Just put it in the chat. Okay, I think they can't hear me. Are you able to hear me? If you have any questions, you can unmute yourself. Yeah, how do we calculate number of occupants?
First thing is there are standards available. There is a standard called ASHRAE, American Society of Heating, Refrigeration and Air Conditioning Engineers. It is ASHRAE. In this standard, all the utilities are described, like functionality, if it's office space, if it's a mall, residential aspects, warehouses, showrooms, and against that they have compiled the data and they have established the anticipated occupancies. So you can refer that table. For ease of your understanding, you can go and search on Google ASHRAE occupancy. The standard is ASHRAE 62.1. If you go in that, you will find per square meter or per 100 square meter what will be the occupancy.
So thank you for that. Yeah, we do have a ASHRAE chapter at Manipal, and I think, but the School of Engineering is connected to them.
See, even in architecture also, I am sure there will be some norms that what are the occupancies you will be considering. We are talking from the services perspective, but there will be some guidelines available for in architecture when you design the spaces, office for 50 people, what would be the occupancy we should consider.
Yeah, the standards per square meter of occupancy that we can. Any other questions? I think no. Yeah, you can. What are the considerations for solar panels for such a project?
solar panels basically needs a bigger space area. If you look at any high-rise tower, on high-rise tower, solars are not very effective. First, because you have a huge amount of services, so the roof is occupied. When you talk about chillers, when you talk about the GSM antennas, we talk about the CCTV surveillance systems, we talk about water tanks, we talk about fire tanks. So we get hardly any space for the high-rise tower. Normally, if the project is of say school, which is horizontally distributed, like years which is horizontally distributed, of G+3 nature, you have huge car parks available where we get the sunlight. In such cases, it becomes a feasible solution. While for high-rise tower, consumption is very high, and against that, area available for solar panels is very minimal, so it doesn't give the required outcome.
Yeah, and another question was about the shaft size for soil pipes. How do you calculate those?
Generally, the systems are handled as 3-pipe system or 3-stack system. One is the soil pipe, which is connected to WC. Second is the waste pipe, which is connected to all wash basin and floor drains. And third is the vent pipe. So space required for these 3 pipes to put together is in the range of about 450 by 450 if it's a square, or it's 600 by 300 mm. So you need to provide 600 by 300 mm spaces for the nearest. You can, if you are giving the shafts common to the offices, say between 2 offices we can have a common shaft which will serve 2 toilets, then a common space of 600 by 300 is sufficient, or 450 or 450 is sufficient, how it suits your layout.
And yeah, one of the question was about number of staircases.
This goes with the civil defense codes. Now, travel distance in case of any fire should not exceed the 30 meters. So maximum span you can have about 60 meters from end to end. So the distance traveled should not be more than 30 meters. So if you have more area to cover, or the running distance is more than 30 meters, you need to introduce one more staircase.
And then the number of elevators, again, it's based on the occupancy. Correct. But is there any thumb rule for it?
Generally, it again goes with the apart from occupants, the purpose of a building. Say a residential building of same area will need more elevators than as compared to offices. So there are calculations available for G+7. Normally 3 elevators are used, and beyond each 10 floors we need to add one elevator each. So from whole scenario I could not understand how many floors we are talking about. I just got the height of the building, so I could not plug that aspect in. But thumb rule, you can consider about 10 floors, 3 elevators, and after that each 10 floors add 1 elevator. Thumb rule.
Yeah. I think that would be really helpful, because as of now, it's like an architectural design project, but in practice, definitely, they're going to look at coordinating with all the consultants. And as you rightly said, the success of a project is communication between all different
stakeholders,
departments that work for a success project.
Yes.
So thank you for your time, and it was really very much very informative and very useful for the project that they are doing, and we'd like you to also see once they come up with their final work.
For sure, feel free, and if they have any queries, they can send an email to our email address, and our team will be responding them with whatever queries they have.
Yeah, so thank you again, and thank you Ashutosh for the coordination.
No problem.
And see you again. Thank you.
Thank you. Thanks a lot. See you.
Thanks. Bye.